My name is Gideon Mendels. I'm the CEO and co-founder of Comet. I make my own espresso at home. I grind and weigh my beans, and depending on my mood, I either drink just an Americano or a cappuccino.
What is happening, good people of Earth? We're back for another MLOps community podcast. I am your host, Dimitri Os. And I've got a little bone to pick with some of y'all. There is this trend going around, and instead of saying, I'm just following up or I'm circling back, tell me if you've noticed the new trend is just a gentle reminder, just a gentle ping on this. There's nothing gentle about it. You're bugging the shit out of me. I'm not answering for a reason. Get over it. No more gentleness. Let's be brute. Let's just be crash. So talking with Gideon today, I had a blast because he's been in the traditional ML world and he recently open sourced OPIC, which is in the Gen AI world. It is all around evaluation, and it's a tool to help you evaluate your LLM or Gen AI product output. And we talked at length about how these two worlds of experiment tracking that he's been doing for the past 8-9 years and the evaluation tracking or world, those two worlds, they're not different. They're actually eerily similar. And so let's talk to him about it. A huge shout out to the Comet team for sponsoring this podcast. I got to say it. They are the reason that we are able to do what we are able to do. Thank you to them and all of our sponsors here at the MLOps Community Podcast. Let's jump in to this conversation. And as always, a gentle ping, a gentle reminder to pass this on to one friend. So, first thing we got to talk about is, what is that solar panel behind you?
It's a photo of an astronaut. I think they're doing a spacewalk, working on the ISS probably. I'm not sure actually, but yeah, it's in our office. I should probably ask where this originated from.
I'm literally looking at it, and for the people that are just listening, in some world, some alternate reality, before you told me what it was, I saw it as a doorway behind you, and it was like, I thought you were back in like the laundry room, and then there was some random solar panel that was stashed behind you overhead that probably was decommissioned or something.
Yeah. Thankfully, the early startup days of working from the laundry room are, 6-7 years behind us. But yeah, hey, it's never too late.
You've matured as a company. You don't need to both be doing your laundry and building your startup.
Exactly.
At the moment.
Yeah. Life goals.
Exactly. So I'm excited to talk to you about OPIC. I also want to just dig into evaluation and evaluation metrics and what you've been seeing out in the field. Also, I think it's probably worth talking a bit about experimentation because you're kind of the OG in that. First off, let's kick it off, man, with you've been out there, you've been talking to a ton of people. What are some key evaluation metrics that you've seen people using?
Yeah, so kind of taking it from the top, right? As for some context, when we talk about evaluation matrix, right? Like you said, we've been doing ML experiment tracking for almost 7 years. And evaluation is not a new concept, right? I think it definitely behaves a little bit differently when it comes to LLMs, and kind of more supervised models. Depending on the task, we have, accuracy, F1 scores. LLMs by itself have kind of more traditional metrics such as perplexity, which is not just a company name. It's an LLM metric or a language model metric. But yeah, I think in the context of people building on top of LLMs, so not necessarily training or fine-tuning, things look a little bit different, right? If you have labels in a supervised model, then all the kind of classical machine learning metrics make sense. When we talk about LLMs, there's essentially the way we view it, and it's definitely task dependent. There's kind of like 3 types of metrics you could use. So let's take an example use case if we're building a RAG chatbot, internal or external. The basic one are just like the deterministic assertion, right? Like I don't want the model to ever say I'm an AI model. So I can search for that string, assert does not contain. So those are like the classic ones from kind of the software engineer world. But as we know, the output of an LLM could look very different from a string perspective, but semantically could mean exactly the same. So these deterministic assertions break very quickly. And then it brings us to like the 2 other sets of metrics, which are call it the heuristic distance-like metrics. So for example, if I have a question that I want my model to answer right, say, what is the MLOps community podcast about, right? So I'm fine if the answer doesn't look exactly the same every time, as long as it covers the main things that I want it to. So I can measure the distance with something like bird distance, or any other type of distance between 2 embeddings between my preferred answer and what I got now. So those are the second set. And then the last one, which is a slightly newer concept, is using another LLM to produce a metric on an original LLM response, which is what's called LLM as a judge. We can use it for the same example earlier. Instead of measuring the distance and, with cosine similarity, I can ask another LLM, hey, does both of these answer look the same? So that's at a high level. That's what people use. There's still a lot to uncover in that space. It's still hard, but I would say those are like the 3 main ones.
So one thing that I want to point out that you mentioned and articulated beautifully is there's a difference between the traditional ML evaluation, because it was more evaluation of the model when you were training it, right? And now with LLMs, you have evaluation, but that's once it's out in the wild, or once it's already been trained, it's already outputting something, you're evaluating the output on that.
Yeah, well, so you're always evaluating the output, right? If you have a simple classification model, you compute the metrics based on the expected output versus what the model actually gave you. But you're right in the sense that like it's no longer a model that you even have control over in terms of training and fine tuning. You could be using OpenAI, ChatGPT 4.0 or something. But you still need to evaluate how well you're doing. So you don't control the model weights, fine tuning, but you do control the prompt, right? And in some cases, some call it production hyperparameters such as temperature and seed maybe. But yeah, so it is quite different.
So then the other piece that you were talking about is this: if you understand the question that's being asked, or if you understand what you're going for, you can use BERT metrics, right? And that's if you know what you want. But a lot of times you have no idea how things are going to be used, or you maybe it's not that you have no idea, you kind of assume or expect folks to use your AI feature or your AI product in one way, and then maybe somebody comes out of left field and starts using it in a different way. So you can't really use those BERT metrics.
Yeah, so it's a good point, right? It's very use case dependent. And sometimes you're right. Like there are cases where you have no idea, just have to put it out there and see what people do with it. If you're building a RAG or something, I would argue that in most cases you should be able to create like call it a goal data set of some examples, questions, and answers. But either way, your point's very valid, because even if you created that and you have some kind of testing and evaluation before you release it, once it's in production, people will, definitely surprise you. So that's a big part of like what OPIC does, right? Because, and there's definitely other solutions that do that. But the idea is like you can bootstrap these data sets, right? So you put your, let's call it chatbot in production. OPIC does all the tracing of all the responses, the questions, the chat sessions, everything happens automatically. And then you basically get a data set that you can either manually label, human label. So person can go and say, hey, this answer was against our company policy, or this answer had bias, or this answer was just pure wrong. And then you can also use some of the built-in evaluation, like LLM as a judge metrics. And then you bootstrap this data set by automatic and manual labeling. So the next time you iterate, you can actually run through those questions and answers. So that's like, I think like when I speak to teams and companies trying to deploy, especially RAG applications, I would say that's the majority of the LLM, not the only ones, but the majority of LLM use cases.
Yeah.
That's kind of what separates, I would say, like those who made it to production. And production could be an internal solution, right? Like, but still, like with the real active users versus the one that put it out there and it kind of blew up. So it's this more data science oriented methodologies versus kind of more software engineering ones, if that makes sense.
Yeah, explain that a little bit more, because I do like what you're saying there. Because the software methodology is, I know exactly what I do not want, so I'm going to say, if you pump out this string, just cancel that, right? But there's going to be a million different ways that an LLM can say that same thing. So all those edge cases, you're going to have to either spend a ton of time trying to cover them all in your test cases, or you do something else. Like, I think, and that's what you're getting at with the data science methodology.
Yeah, absolutely. So like, first of all, like it's really fascinating to see like there's, I would even say the majority of these people that I spoke to building LLM applications are software engineers, which is great. Because like being a good engineer helps you move so much faster. There's obviously data scientists who are amazing engineers as well, but it's like a slightly different paradigm. But to your point, it's very accurate, right? In the software world, testing is a huge component, right? Like there's books and methodologies and unit testing, integration testing, smoke testing. Like there's a lot of way to test software, but essentially all of those break when you try to test an LLM application. Because to your point, I can write assertions, unit test, integration test assertions, expecting a string. But an LLM, your LLM provider updates their version, you're going to get a different string. And probably, hopefully, a better one. But you don't want to break the build because of that. And you don't want to go and change all these strings again. So that's where you need that fuzziness, if you call it. Which adds risk as well, right? But it's this deterministic versus non-deterministic nature of software and data science.
So the fun part there is the idea of software engineers moving more towards understanding data science paradigms, and then vice versa, data scientists moving more towards understanding software engineering paradigms, which I think a lot of people on the internet and on social media have been screaming about for a good couple years. Like, data scientists should learn how to code, or they should at least learn how to use Git, or software engineering principles at the very least. You're the first person that I've heard to say vice versa. Like, software engineers, if you're dealing with LLMs, you want to start to understand the nuances of that fuzziness.
Yeah, exactly. Right. Like, so by all means, I think data scientists should pick up as many software engineering skills as possible. The best data scientists I've met in my career were like brilliant software engineers as well, right? It's just, it goes together. But I think, so first of all, I think what we're seeing is the two fields converging. Like, don't get me wrong, you're still going to have the pure research, data science, machine learning people like deeply understand the math of these optimization algorithms and loss functions, and there's still definitely going to be that group. But I think the majority of the use cases around machine learning and AI will be this convergence of, call it software engineer, data scientist, but being able to use those things. But there's still a lot in the data science methodologies, just way of thinking, that I think software engineers who've never been exposed to that before could benefit a lot from, right? Like in data science, it doesn't matter which task you're working on or which, algorithm or model you're using, but it's an experimental approach, and specifically a metric-driven approach. So you generate, assuming a task, you have a data set, hopefully with goal data set, so you know what the right answer, what the right output should be. And then you start changing them, in this case, the prompts, the pipeline, these parameters. And every time you run one of these experiments, you test it against the data set. Now, you still want to look at the data and all of that, but it's not this vibe check approach. It's more of a metric-driven approach. And then with that, it opens up this can of worms of all the things you should be aware of, overfitting and such. It's still a risk in this case, right? Even if you're not controlling the LLM, if you have a small goal data set and you're really tuning the prompt to 10 or 15 answers, you might overfit, meaning it will look perfect on those 15 answers, but then when you start putting it in production, it will fail. So that way of thinking is just, it's really the only way to go here. So I'm really, it's exciting to see a lot of software engineers pick it up. And that's a very huge focus of what OPIC is kind of trying to bridge those two paradigms.
Have you seen a way to unit test LLMs that are super helpful?
Yeah, so I guess the pure definition is of unit testing of there's two sides of unit testing. There's a philosophy. You should test what you should test and how does it look like. Obviously, in an LLM, you don't control the internals, but I think the idea here is, again, having some deterministic simple assertions is very helpful, but they're very brittle in that case. So that's where you want to start including more heuristics and LLM as a judge ones.
And talk to me about LLM as a judge, because I know there's 50 different ways to do that. Have you seen certain ways that folks are gravitating towards more?
Yeah, so LLM judge has its benefits and definitely some disadvantages. I wouldn't say there's for a specific judge, call it hallucination detection or bias detection. I wouldn't say that there's necessarily a way how everyone does it, right? The prompt, LLM as a judge is a fancy name. It just basically means you take the output of your original LLM and then you tap on it a prompt that asks a different LLM or even the same one, hey, does this contain bias, right?
Right.
But so obviously people develop those prompts, and those prompts are also perform differently on different LLM providers. So I wouldn't say there's necessarily a method that everyone uses. It's really excited to see OpenAI in their last dev day actually released some form of in their playground, an LLM as a judge mechanism there. So they wrote the prompts for them, and knowing OpenAI, they probably did a good job developing those prompts. So that's great to see some form of consolidation there. The one thing I would say I've seen people do, LLM as a judge and LLMs in general are, depending on the scale, could be very expensive. So I've seen customers use a lower or cheaper LLM in production, but then use an expensive judge to test it. So then you kind of get best of both worlds. That's one approach I've seen.
Interesting. Now, coming back to OPIC, because I wanted to dig into one of the pieces that you have around it, which is that track function. And for those who don't know, my understanding of it after reading the GitHub page, because it's fully open source, which is awesome to see, is that you can track just about anything that you want when it comes to these LLMs, as long as you tag it with hey, this is important to me, I want to track it. Is that correct?
OPIC is fully open source. From a functionality perspective, it's exactly the same functionality we have in our cloud hosted version. So it's not a crippled product or anything like that. You can actually run it for production use cases at very large scale, just from the open source project. But to your point, yes. So it comes with built-in integrations with like the major LLM providers, like, you know, the major libraries like, you know, Llama Index, LangChain, Ragas, and so on. But even if you're not using any of those things, you pointed out we have this really cool way of auto-instrumenting your pipeline. So just by adding annotation at track above your function or class, we will track basically everything that's going on in your, call it chain or pipeline. So yeah, I think you had the right idea there, and we've seen people track pretty, you know, different use cases and products with it.
So that's everything basically on your side, or if I'm creating an app, I can track whatever on my pipeline. I also wanted to get into, can we track the responses of folks or signals that will help us understand if the response was valuable? Like something like if someone copy and pastes this, or there's the thumbs up, thumbs down, which I think we as a community have come to understand that it's not that valuable, just because people that give you thumbs up or thumbs down may not be the best user segment that you actually are trying to shoot for, or whatever. There may be a lot of reasons why that can be biased or not the best signal, but a great signal could be you get one answer and then you don't ask for any follow-up questions and you copy paste. And so that could be something that is really interesting. Or if there are follow-up questions, then you can see what parts of the follow-up questions it's trying to dig into. And all that stuff I can imagine could be valuable for the app developer. Have you seen any of that?
Yeah, absolutely, right? So it depends on the use case, right? Like OPIC is not just for, call it chatbots or RAG applications. It's for essentially any LLM powered feature. And by default, we'll track the, you know, the input of output of the LLM. So definitely in the chat example you gave, you'll definitely see the responses. Now, I think where you're going to is like, hey, can we feed in additional, call it features, BI features or other ones, so we can later understand how well the response was. I haven't seen people use a copy paste one. That's actually it's a cool idea. But we've seen definitely people feed in like a downstream, call it product analytics event.
Oh, nice.
You can create essentially all these quality evaluation criterias on OPIC, both again that you can manually tag, but also automatically, right? So in your example, I think you said, hey, this user based on this answer did like an activity in the product. You can add that as a, call it categorical annotation. And then again, you bootstrap this data set. So later when you're reworking and improving your prompt, you can actually test how the new prompt does on those things. So it's pretty cool. Obviously you wouldn't be able to simulate whether the user did that or not, but it's a very good proxy for quality. So
yeah.
And I think it, you know, brings the question, can we actually feed it into the training process down the road? But that's an open research question.
Oh, yeah, that's fascinating to think about how, and the other piece to think about is not just, all right, we get that information, but then with that information, what do we do with it? Right? So cool. Yeah, I understand that when we have this certain snapshot of prompts and temperature and RAG, retrieval, whatever, the whole system, we have that snapshot that is tracked. And we see that it performs higher on these types of queries or this type of task. And we think that because we're seeing more copy paste or we're seeing whatever that metric is that we're tracking downstream, like you said, like the product analytic metric, now we have that. What do we do with that?
Yeah, so I think you know, we're talking kind of hypothetical. It's very use case dependent. But like, for example, if you're doing like an A/B test, right? So you're running two different LLM variations or prompts and production, and you're testing these downstream product analytic metrics, like very quickly, you know, you can know in production which one's better, which is pretty big, right? When you think about it. Now, that's what I'm saying, is very dependent. In some cases, you don't have those things. And then, like, I think in some scenarios, maybe, and I'm sure if we look on archive, there's, I don't know, 50 PhD students working on this. But I think in some cases where you have those kind of production labels, call them, you can start thinking of how you merge both like the traditional ML approach of things and this LLM approach. So just thinking out loud, right? If you have an embedding vector of features, right? So like user information, for example, and then you have some kind of downstream supervised task, like did the user buy the product or not. I'm just trying to keep something simple. Then sure, you can add it in the prompt today in many ways, that context information, which is what people are doing. But it would be pretty cool to think, like, can we actually fine tune the model with these features? Like, there's similar to how people do RLHF, which is, in this case, it's not human, but or I think there's direct approaches, DPO, if I'm not mistaken. You basically, train a model on these so it'd be cool to see, right? Like it is so early and this space is moving so fast. So I think as companies and use cases start hitting the limits of what they can get by just changing up the prompt or their RAG or the vector database parameters, we'll start seeing more of these sophisticated approaches.
It's almost like, because it's been quote unquote democratized, we all can have our wacky ideas and just test it really quickly. And so that's where you get, hey, you know what? If we use a graph database, it kind of works better. Let's try this. And now we've got this thing called GraphRag, right? And somebody can come out with a random paper, and next thing you know, a few folks are testing it and seeing if it's reproducible and it's actually giving them some lift in what they're doing. And so I wonder if that is an area that we can see more exploration in. That would be really cool, just to marry those product analytic metrics with more of the training process to say, can this give me a better LLM? Or maybe there's nothing there and it's absolutely a dead end. But it's fascinating to ponder, and I'm sure it's going to be somebody else that's doing it, and neither you or I are going to go and try and figure that out. But if anybody out there is listening and they are working on this, I would love to talk to them, because it's really cool to think about.
Super cool to think about. And that's what I love, about kind of the research world and like my past life before Comet. That's what I did. It's just like, like in many cases, like we're throwing spaghetti on the wall and seeing what sticks. But like once someone finds an approach that shows promise, like people build on top of it. And that's like how we got to where we are, right? Like transformers and the attention and all you need paper is a mix of like, a bunch of different approaches that we already had at that time, right? I was actually at Google when that paper came out. I had nothing to do with it, but it was written like a few buildings from where I was.
Nice.
And we're using at the time LSTMs with attention, and sure, there's like a lot of differences, but also it's not that different. And I think now people are talking and starting to show that in the right scale, you can even make those like older algorithms like RNNs, LSTMs, GRUs perform closely to transformers. So it's pretty cool to see how much progress we made based on like thousands of people just testing different ideas and approaches.
Yeah, getting the ability for it all to fan out, and then you have survival of the fittest happening. And so
absolutely,
it's cool to see. And it also kind of dovetails into this next topic that I wanted to talk to you about around version control and almost like experiment tracking. You have parallels with evaluation, right? And it feels like they're almost like brothers or sisters. They're siblings in a way, because you want to be able to, in experiment tracking, you want to be able to have a snapshot of everything so you can go and reproduce it and be able to get that model or that same output. And the same with like LLMs and evaluation, and being able to have a snapshot and say, okay, now I want to be able to get that output all the time. I don't want it to be just some random thing that because I had one prompt that was tuned really nicely and I forgot what I saved it as, or I forgot exactly how I worded it, now I can't ever get that output again.
Yeah, no, that's amazing, because like that's really how we got to build OPIC, right? Because Comet, the original focus is on the MLOps side and experiment tracking, right? Like we have over 100,000 data scientists using that, and we power some amazing ML teams at like Netflix and Uber and Stability AI and Cisco and many, many more. And what we started seeing is like our own user customer base kind of trying to hack the existing experiment tracking solution for these use cases. Because like when you think about it, you're right, like they're very, very similar. So in traditional ML, you have, what do you control as a data scientist? You control the data set, you control the hyperparameters, you control the code or the algorithm, and then you part with intuition, part with like methodologies. You keep changing those things until you get a metric that's satisfactory. And I'm not even getting yet to like the reproducibility side of it, just like the nature of it. You're testing many, many, many things, and you're trying to get a better result, right? And then when you think about these like LLM applications, so yes, you control different things, right? You don't control them. I mean, let's start with what you do control. You control the prompt. You control some LLM parameters. If you're building a RAG, you have all these, call it hyperparameters around chunking and configuration of how the database does the re-ranking and so on. And then you can create a test data set like we spoke before, and you can continue iterating on those things until you get a result that's satisfactory.
Yeah, so, the embedding model too. That's one that you could...
The embedder, absolutely. Absolutely. Yeah. You want to test different embedders, you want to test different LLM providers. Like you're searching that space. It's very, very similar. Yes, you're changing different things, but you're still blindly searching a space, right? You can't run gradient descent on it. Like you have to blindly, with intuition, of course, and knowledge, start tweaking things until you get a result that's good enough. So it was really fascinating to see users trying to use common experiment tracking for that, right? And you can get a pretty close to what you need, but then we want to track the traces and the spans so people can look at the data, right? And we want to include these built-in evaluations because that is what we saw customers needing to manually implement all the time. So yes, so like very similar. And then that's like the main layer of like the main value proposition of experiment tracking, whether it's an OPIC or Comet EN, which is I want to help you build a better application, better model. But on top of it, and you called it out, right? Like you have this notions of like reproducibility, right? Like I have multiple people working on this project. I want to pass it to someone else. They need to know exactly what I did to get to this result. And then the other piece is collaboration, right? Because if you don't use something like OPIC or Comet EM, like it's basically impossible to collaborate. I mean, you can copy paste logs to Slack all day long, but Dimitris, if we're collaborating on something and I want to show you, hey, this is the prompt, these are the outputs, like how do I share this with you today? Like I put it in an Excel sheet. Sure, you can use Excel for everything, but so it's really cool to see like two products that are like, they have so much in common, and it's, also from a user and customer base perspective. So when we identified this about, call it like 18 months ago, we decided to double down on OPIC and build it. And, we wanted to give it back to the community in this case because we have a strong foundation with our existing platform. So we made it completely open source as well.
It's almost like the microcosm of the macrocosm we were just talking about. I want to highlight that real fast, where what you're doing when you're exploring this unknown space in your own prompt pipeline or your own LLM application, or creating a traditional ML model and doing your experiment tracking. That's exactly what we were just talking about with the advancements of AI.
Is it?
And it's just that for this, it's me going through on my computer working on it. But then for the advancements of AI, there's hundreds or thousands or hundreds of thousands of us that are all trying to figure out what the best ways to optimize this are. And we're all just exploring this unknown space together. And then whatever we see hits. And we kind of run towards it. And so it's cool to think about that from the micro to the macro and how there's those parallels. But the other piece that I wanted to mention is this collaboration factor, which I think is a huge part of what's going on, since collaborating is almost like a must in certain ways, because you don't want to just have it all for yourself, or you want to see if you can get a fresh pair of eyes on something. What is it that I'm missing here? What do I not know? And can I ship it over to someone and see it?
Yeah, that's a great question. So essentially OPIC has, let's call it like three main views. I'm talking about the UI, right? Like there's a very robust SDK and an extension to PyTest that allows you to add these evaluation metrics. But so and depending what we're trying to collaborate on, right? So let's start with the basics. Like we have a data set. We created a data set. So I can share you a link to that data set. You can have, obviously multiple ones in the UI. You can look through it, see all the inputs, expected outputs, and so on, whatever columns we have there. Not that different from an Excel table at this point. But then you want to start annotating things, right? Because we established like you really want to have this notion of what's good and what's not good. So I can share this with you. You can go in and annotate, different samples. I can annotate samples. I can send it out to a, external, human annotator as well. And then we can also collaborate on which annotation categories that we care about, because it's never as simple as like, this is good, this is bad, right? Like it's more complex than that. And then the last, like call it the third main kind of view is call it the observability view. So we put this in production, and like, you're a product builder, you're an engineer, you want to see how people are using it. So with OPIC, you can actually see all these sessions, and then for each one, you can actually see a full breakdown of the traces and the span. So if you have tools that you're calling within your chain, you can see what their response is. So you get just full observability of how people are using it. And then, I can select a specific trace and, share this with you, Demetrius, and say, hey, like, this seems odd, or we should fix this. So it's been pretty cool to see how many people use it. The product's only been officially out we're recording this in October 4th. It's been like 2 weeks.
Nice.
Already reached, I think, 1,500 stars on GitHub and hundreds of users. So pretty awesome to see how people use it.
Yes, and I definitely saw it when it came out, and I was very curious, and that's why I'm happy that we're having this conversation. I also wonder if you can, because I wasn't clear on this, are you getting a snapshot of someone's whole, like we talked about how there's all these X factors or knobs that you can tune when you're dealing with your RAG pipeline. Let's stay centered on like a RAG use case. And you've got the way that you're chunking it. You've got the re-ranker. You've got the embedding model, the model that the actual LLM you're using, the provider that you're using. All of that feels like it should be caught in a snapshot if you want to reproduce what you want to reproduce. Are you getting all that information too?
Yeah, absolutely. We have this notion of experiment configuration, which is exactly those things, right? Like it's a snapshot of all these knobs and parameters, so you can easily reproduce them. But then we go like deeper, and we can see like, in a RAG use cases, you want to see, you don't just want to see what the question and answer was. You want to see like what is the what did the vector database return? What was kind of pasted into the prompt template? So you can really dig in and see all those things. So which helps iterate on a specific parameter versus the whole system as a whole all the time, right? Like maybe it's your chunking. Maybe you want to add traditional BM25 input as well, which is, by the way, it seems to be extremely powerful and useful to include those things. So yeah, it's called experiment configuration.
And that is exactly what I was thinking about, is how valuable that can be in the collaboration aspect, because I can send you over all of that experiment configuration and you can pick up where I left off. And so then you can be like, yeah, oh, you know what? Maybe you have some inkling of something that 2 weeks ago you were playing around with a different configuration and you saw it was cool if you switched out one of these parameters, and then boom, you see a lift and you get to see some gains there. I also wonder about the actual output and that data set that you're talking about, and then being able to zoom into different pieces of that output and say, you know what, this is doing really well on everything except for maybe this slice. And I imagine you've got something like that, because that also doesn't feel so different than the experiment tracking worlds, right?
Yeah, absolutely, right? So on the data sets or the experiment side, there's one of the things you always want to do is compare against something, whether it's a goal data set or experiment A versus experiment B, right? So you have the evaluation metrics and you can look at how does this experiment perform versus the other. But when you look at responses, you also want to be able to see like an actual text diff, right? Like this is how they responded differently. And then, yeah, you can kind of slice and dice based on like, I guess, show me all the data set items where this evaluation score is equal like 0, for example. And that's really, and then you look at the ones where you failed in, and then you go back and iterate on the prompt and you try to fix it. So that's exactly the process, which is very much, back to our previous point, very much a data science oriented process versus a software engineering one.
So I can really take that data that is output and I can dig deep into each little piece of that and understand what it was when it was output this way. Okay, all of these, like you said, whatever it is, if the evaluation score is 0 and I'm looking at all these examples, I can know exactly what was pulled from the vector database or what kind of chunking happened. I can understand if there is something in my pipeline that is not working. It's a little bit easier to debug that.
Absolutely. That's the goal. And then you mentioned something that's wrong in your pipeline, right? So I think that most of what we're talking about is call it in like this development phase, right? And then maybe you have, it's an iterative process. You put in production, you start getting new production data, you label it, you go back to development, right?
Yeah.
A huge piece here that like I'm very excited about, because I haven't seen anyone try to approach it the same way we do, is like the CI/CD aspect of things, right? Because in software engineering, after you build all your tests, every time you release something, not even to production, right? Like every time you create a pull request on GitHub, there's a build and it runs through all the tests, and it gives you so much confidence that whatever you didn't break someone else's work or some old functionality. But like, how do you do that when you have an LLM in place?
Sure.
Like, right? So yes, we talked about the evaluation metrics, whether they're deterministic or heuristic based, but like we really worked with our customers to try to figure out like, okay, but what is it? How do you use this in the CI/CD flow? So what we ended up doing is we built an extension library for PyTest. So essentially within your existing like testing code, you can add additional tests and say, okay, this is a heuristic test. I am okay if the distance between the answer in my goal data set versus the distance from the LLM is lower than some threshold. So, and then you get that additional confidence that you didn't break anything, right? So even if it's not LLM related, if you change something, let's say something's broken in your vector database pipeline, like, yes, you can write some software tests for that, but this is really a really great way to have this confidence to ship. And then that just allows you to move so much faster because you're not worried all the time you broke something. So it's really been like really cool to have that opportunity to take a concept that is so meaningful for software engineering and try to bring it to the LLM world. And I'm just excited to get more feedback. I'm sure there's a lot we should fix and improve. So it's been really fun.
Well, the thing that keeps screaming in my head is feature flags. And have you been thinking about how to incorporate, because it's like a natural thing that you would try and want to have, right? Is that, all right, cool, we're going to test out this new one and we're going to slowly roll it out into production, or we're going to roll it out just in this area or that area because we have 100% confidence that it's doing well here. And then we might do a little bit more of a rollout. So you're A/B testing on that rollout, or I know some people call it like whatever, the champion challenger kind of rollout. Have you thought about any of that, or is it you're just playing in the evaluation side and then reincorporating it back into the CI/CD pipelines, but not quite going as far as the deployment piece?
Yeah, so OPIC doesn't, or Comet for that matter, we don't do any work around kind of production A/B testing. A lot of people, when we say experimentation, assume that's what we do, but no. So now it might change, obviously, right, depending on what users and customers are asking for. But that's like the existing platforms and tools for A/B testing, and essentially every company uses something, right? I think like translate well here. So we're not trying to build something that is super established and people have been done before and just kind of like put an LLM tag on it, right? Like if the existing tools work well, like by all means, let's use them. It's about like where the existing tools don't work as well for this new paradigm where we get excited about adding more functionality. That's like the history of the company as well. We had Git version control, but it just didn't cover all these other things we needed from experiment tracking. So that's kind of, so I guess the short answer is like, we don't do any A/B testing, feature flags, functionality, but there's some great tools out there.
Yeah, but it's like you work well with that. And then along those lines, are there ways that you've seen folks architect their pipelines to have them be more bulletproof or resilient? Maybe not resilient, but just be more accurate and have more success in their AI products?
Yeah, I mean, there's a bunch of ways we can break this apart, right? Like, and there's obviously a lot of knowledge in data engineering, software engineering of, how to build reliable data pipelines. So I probably not much to add there. I would say, like, without, try not to repeat myself, but like, I think the main thing that adds this new layer is around including automated evaluation testing for your LLM outputs. That's like the new thing that is hard to do with the existing knowledge that we have around data and software and engineering. And I've seen teams that adopt that approach and suddenly just move 10x faster. So that's been really amazing.
And there's this notion of the evaluation. Basically, one thing that's hard with evaluation is the human labeling and how expensive that can get, right? Have you been seeing anything that will help that besides the LLM as a judge type of thing? Or is it just, you know what? The best teams hold labeling parties and they embrace the whole labeling piece of it.
Yeah, I mean, there's like ways they can get closer, but at the end of the day, you're right. Like good human label data is priceless, and it's very similar to traditional ML, right? Like there's definitely companies that will outsource that work for you. If you're a smaller team or don't have budget, labeling parties are always a great idea. But yeah, like having even like it's just crazy, even a small amount, like even like 50 or 60 samples and like on a Q&A RAG use case will help you so much. Like so definitely recommend, if you don't have that, just go ahead and label a little bit of data. It also gives you a lot of insights once you start doing that about how to design your prompt.
And have you seen differences between like internal versus external facing LLM applications and how to evaluate things there? Because I feel like you can get into hot water on both of them. And so maybe there's no difference. Maybe with the internal stuff, you have a little bit more leeway because you're not going to get thrown on the front page of the internet, or at least unless your employee
Less likely to, yeah.
Yeah. Yeah. But I don't know. Maybe there isn't a difference, and it should be taken with a lot of rigor on both cases.
Yeah, I mean, it depends on the use case, right? Like, and I think most companies, for that reason, start with like internal use cases. There's less risk in there. But I mean, look, there's there's companies building internal HR chatbots or RAG chatbots, and theoretically, like one can just answer questions about other people's compensation, right? So there's risk there as well.
Yeah.
That's one thing. The bigger difference, and the main one I would say, is usually the scale, right? Like if you're putting something in production in front of like hundreds of thousands or millions of users, it just it gets much harder in many ways. So that's more of an engineering thing. Yeah, but it's been cool to see like some of our customers starting with internal use cases, getting a lot out of it, moving to like beta where some of their customers have access to it, and then finally putting it in production. It's such a good feeling to see like someone does that, and like as a builder, like it's so hard to build things that are good and bring value and people are excited about, and seeing our customers do that, like literally what gets me up in the morning.
And when you talk about the scale between the two, internal versus external, I also, since we are really harping on evaluation, how do you manage the scale and doing proper evaluation at scale?
Yeah, so the first thing we had to do when we built OPIC is like support that scale, right? Because if you have, hundreds of thousands of users or millions of users, and, I don't know, a very significant number of QPS, like we want to do the observability side for that, like we have to support that, right? Like, so OPIC was built from the ground up based on a lot of the knowledge we already had around model observability to support that. So that's the first thing that's hard, right? Like, how do we collect all these instrumentation information from you in real time without slowing down your application in scale? So that's the first piece. If you're listening and you like that kind of work, definitely take a look at what we did there on the implementation side. We would love to get some feedback. We're pretty excited about it. But then you're right. I mean, just because like the evaluation is also really hard. So all these queries we talked about, slicing and dicing the data, running automated evaluations, it just becomes much harder and scale, like many things. But this is where this world is going to, right? Like we're talking about features and use cases that will be served to like millions of customers. And maybe it's a nature of our existing customer base where we serve, some of these very, very large, you think about Netflix and Uber and the amount of users that they serve, that we have to think about those things. But it's really hard. And we're still early on, both OPIC and an industry in general. So I think if we meet again in a year from now, I'll be able to tell you a lot more on what breaks when you get to that scale.
And one thing that is classic observability type of feature or best practice is setting up alerts. Do you have that ability with OPIC, and have you thought about that type of thing? Because
That's a good question. Yeah.
it's
So we
also
don't. Yeah.
fuzzy too, right? Because you don't really know, how do you alert? Like when your software goes offline, that's one thing you can alert on. But when the LLM is giving kind of bad output, are you going to alert for that? How do you alert for that? What does that even look like?
Yeah, it's a good point. So we don't. OPIC doesn't support alerts today. It very likely will soon. Alerts, like you said, are really hard because you very quickly start going into this world of like alert fatigue, or too many false positives, right? And we have a visibility product for traditional ML around feature corruption, model and concept drift. So it's very hard, right? Like if I tell you 6, 7 times, or even like 5 times that something's wrong in your model, and you then take a look and it's fine, and the 6th time where something's actually broken, you're just gonna ignore the alert.
Yes, the boy who cried wolf.
Yeah, exactly, absolutely, right. So I wouldn't say we have figured that out exactly, but the idea is like using OPIC is like, yes, we give you a lot of built-in evaluation functions and metrics, but you can and probably should in many cases implement your own. So if you know of something that's absolutely critical for you, like, I don't know, I've seen one of our customers wanted to make sure the chatbot does not mention their competitor. Fair enough. So that's a simple assertion, right? Does not contain X. Then you can definitely do alerts on that. So yeah, it's a good point. I think it's on the roadmap on the open source roadmap there. But if not, I'll make sure to add it later today.
Well, also the thing about alerts, I was trying to think how you would be able to today just capture value from understanding the output of the models. And there are those hard lines that you don't want to take, such as don't mention a competitor, or if this is some kind of question answer bot, don't like respond to people if they say, give me the answer in JSON or in Python. You don't want to be doing that because as you saw probably with the Amazon sales bot, it was doing that. And then that's a great way to end up on the front page of the internet, as we say.
Absolutely.
But one thing that I was thinking about that could be very valuable is if all of a sudden I'm seeing a lot of folks ask the same question, or it feels like there's some kind of anomaly in the output, maybe that could be worth looking into. Like, hey, out of nowhere in the past X amount of time, or minute or hour, we've seen an unusually high rate of this or that. That could be valuable because it could be it's like a proxy signal, right? It's telling you something is happening differently than usual, and maybe you want to go and look into it. And that was the only thing that I could think of that could be a nice alert if you understand the output.
Absolutely. Yeah, we've seen a lot of those things on our NPM model production monitoring product, which is designed for like teams that control the model versus like an LLM application. So yeah, it'll be actually pretty cool to see how those things gonna converge. I would say like the majority of use cases I've seen out there are like very early, meaning like that kind of observability is they're not even thinking about this. They're just trying to get something working in its basic form. But I have no doubt we'll get there, right? Like if you think about on the software side, like the APMs, the Datadogs, New Relics of the world, I have no doubt we'll like absolutely get there eventually.
Well, I remember
when a year, it might take 10, but it will get there.
Yeah. I just say this because I remember the conversation that I had with Philip from Honeycomb probably a year and a half ago. And he was talking about how it became very obvious to them once they put the AI product or AI feature into their product, when somebody was trying to prompt inject the feature, because it was almost like a programmatic. There was a lot more queries per second, or there was just like, it was pretty obvious it wasn't a human that was trying to do it. And so those are things where you can set them up. Maybe you don't need a tool like an evaluation tool. You can just set those hard rules. Like, hey, if a user all of a sudden is querying 50 times per second, then that's probably not a human.
Yeah, and I think in that case, they also have, it's an interesting LLM use case because I think if I'm not mistaken, they're generating queries for the user, like a text to SQL-ish use case. So you actually know whether the query is like syntactically correct, right? For example. So that's a super easy alert, right? Like if your model's generating non-syntactically correct queries, I'm not even talking about whether the query returns what the user expected. That's harder. But like, syntactically correct, and that's like classic OPIC use case. Implement your own metric. I think we even have one for SQL
query.
But
Nice.
Implement your OPIC metric and add something around that, and then you can have these alerts, or even just this information on the UI that like these are the use cases that break, or so on.
So it's almost like you can today get alerts. You just have to do a little bit more creative thinking.
Yeah. There's no alerts like built in. I mean, you can forward the logs and so on. If you want to hack it, I'm sure there's a way to do it. But I definitely urge the listeners, if you want to go and open a pull request for an alerting system,
There we go.
Integration to Slack, PagerDuty, and such, we would love to accept it. Yeah, it's an opportunity, right? Yes.